In this problem, we are given a particle accelerator where a charged sphere of a radius r and density has its speed increased from u to 2u. A first year GRE student derive the formula to say x is simply going to be 2 pi r cube u square density divided by 9 power. So our task in this problem is pretty easy. First thing which we need to do is to simply show that this formula is dimensionally not correct. The second part is that we need to give that there is only one error in this formula. That is for x, since that is what we're solving for. So to obtain the correct formula, we're going to start by applying the dimension analysis to verify if the given formula is dimensionally consistent. So in order for us to identify the dimension, first thing we need to do is to identify the dimension of each variables. From the formula here, we have x, which is equal to 2 pi. We can say the x is the quantity which we are looking for, and let's assume it to be distance. Notice that distance, that is the dimension of distance, is measured in length. Let's say if x is distance, and this is simply going to be length. Therefore, x is going to be the dimension. We're going to put in bracket to show that this is a dimension and this is going to be length. The next thing which we have is the radius, which is r. And notice that this has a cube root. Here we have r3. And notice that the radius also is measured in length, which is going to be L to the power of 3. Here we have u, which is speed. Notice that speed, this is simply going to be distance divided by time. And distance divided by time is also measured in length. So in this case, we're going to have LT, but with the power of 2. And next we have is the density. Density is simply going to be mass divided by volume. And this is the same thing for dimension is going to be ml negative of 3. And here comes our power, which is going to be ml square t negative 2. So what do we need to do next at this point is to simply express the formula in terms of that dimension. I'm going to do that by using what we have as the formula, which is x equals to 2 pi. So if we said x is simply going to be 2 pi r cube u square density divided by 9p. This is going to be x, that is the dimension of x is going to be 2 pi. Put it in dimension, r cube, and here we go with u square, and here comes our density. We're going to divide that by dimension of 9 multiplied by the dimension of power. So notice that what we have from the beginning of this equation is the 2 pi. And here we have the 9. So 2 pi and 9 are dimensionless, so they don't affect the dimensional analysis. We can simply ignore them and write this down. Here we're going to have x, which is going to be dimension of r cube, which is the radius, into the velocity square, and here comes to the density, divided by just the power, divided by the dimension of p. So what are we supposed to do next is to simply, replace the values. What do we have as r cube? Let's use this space. The x we said is going to be length. Therefore, we're going to have the dimension of length. What about r? For the r, we call it L cube, which is going to be into bracket of L to the power of 3, we close the bracket. What about u? U is going to be L squared, and here comes a density, which is going to be ml negative of 3. We're going to divide that by, let's divide everything here by p, and p is going to be bracket of ml square t negative of 2. So at this point, we need to simply simplify everything. To make it ridiculously easy, notice that here we have Ru density and then P. I'm going to write that down. This is going to be Ru density and then P. For the R, here we have, there is nothing to simplify there. It's only one value, which is going to be L to the power of 3. For the density, for the velocity, is simply going to be L to the power of 2. And here comes the density. Sorry, I think there is a little bit of mistake. Let's go back a bit. For velocity, it's going to be LT negative 1 to the power of 2. So if that's the case, then here we can erase this and put it nicely. Velocity is going to be LT negative of 1 to the power of 2, in which we are going to multiply this 2 by everything inside of the bracket. And this is simply going to be a bracket of L square T negative of 2. For the density, we have just single, which is going to be ML negative of 3. And for density, for power, for the last part, is going to be ml square T negative of 2. So now that we have simplified, we can divide it numerator and then denominator and see what we can do next. At this point, we can take the first one, which is R. Notice that our R, U, and then density is our numerator, and here comes the power to be our denominator. So the value of R is going to be L cubed, which is going to be the dimension of L cubed, that is length. We're going to multiply that by, what do we have next, which is velocity. And notice that velocity is simply going to be L squared, that is the simplified one. I'm taking this. So for velocity is going to be L squared T negative of 2, and close the bracket. You multiply that by our density, and our density is going to be ml negative of 3. So at this point, I'm going to check our numerator. Sorry, if this is numerator, here is going to be denominator. We are going to take our denominator upward. And what we have initially for power is ml squared to the power of negative of 3. So if you take it upward, here is going to be ml squared to the power of t negative of 2. Isn't it? So we can divide both sides, but particularly the right hand side, are going to divide it by the original denominator, which is ml squared t negative of 3. And here we're going to divide it by these values, which is going to be L cubed multiplied by L squared t negative of 2, multiply that by ml negative of 3. Notice that this will cancel out, this will cancel this, and this will cancel this. And what you're going to be left with is ml squared t negative of 2 divided by ml squared t negative of 3. So ml squared is going to cancel out, and you're going to be left with t negative of 2 divided by t negative of 3. If this cancel out, you're going to be left with 1t. Isn't it? So this is for the first part. If you notice from the equation, we assume to say our x as I'm saying, from the equation we assume to say our x, which is distance, which is measured in length, isn't it? So that is for our right hand side. At this point, our left hand side, we have it to be t. Therefore, the right hand side is not equal to the left hand side. And if that's the case, they are not dimensionally consistent, and that is what we are asked to prove. So the second part is given that there is only one error for this formula, for x obtained correct formula. So how can we eliminate that error? I would like to make it, much easier. You see, if you noticed here, length, that is the speed, isn't it? What we need to do is to simply multiply the original equation by what we call, but what can give us, by just trying to convert t into L, right? We need to introduce a factor that has the dimension of LT, -1, and that factor is going to be velocity, or speed rather, isn't it? Okay, let's erase this. The original equation we said is L into 2 pi r cube u square. We multiply that by density into 9p. So after the workout, what we get is L equals to t. We can multiply this by u. This is the same thing as saying L equals to t multiplied by LT -1, which is the same thing as saying L, which is going to be equal to t multiplied by L divided by t. At this point, t will cancel out, L is going to be L. So this is it for this problem. I hope you find it very helpful. If you do, don't forget to just do me a favor by subscribing to Geminic Science. Thank you. In this